let's start with the second day of lectures. So this is the agenda that we have. So in the morning, you will be seeing a lot of me and Professor José Luis Hernandez, because we have 3 sessions plus a bridge session with the software architecture part in the afternoon. At 11:45, we will have an invited guest speaker, Joris Sais, which will show more practical aspects of software architecting in robotics. And in the afternoon, we will have Ivano Malavolta talking about architecting ROS systems, robot systems with a focus on ROS. And we will have Ilias Gerastotopoulos later on self-adaptive systems. And I will wrap up with a practical, a lot of robot videos about self-adaptation in robots, let's say. And hopefully we will wrap up with a nice panel discussion with all of us at the end of the day. So without further ado, let's start. What time is it? We are 7 minutes behind. With a news article that José Luis pointed me to some weeks ago about the automotive industry and their struggles with systems engineering. They are reinventing the wheel. To put some numbers on this struggle, Forbes, who was publishing this article, in 2011 estimated that developing a new car model required around 10 million lines of code, and it was 6 billion of costs to develop a new car model. If we extrapolate this to an autonomous car, which many say will be the cars in 5, maybe 10, maybe 30 years, there's discussion on that, those are estimated to have around 1 billion lines of code. So you can extrapolate how costly it is to develop a new car model. And the industry is struggling with every new model. And one would think, well, if you want to save costs, you would reuse your designs, right? Surprisingly, things are moving backward. They are having more customized designs that are not reusable. And this is because they are struggling with doing systems engineering and architecting. So there is a lot of confusion about the role of systems engineers. They think they are project managers. And this results in, for example, and I'm citing from this article, you can find examples of a bug that cost to fix. And after some investigation, it ends up, it results that it was coming from a requirement that was misunderstood. So basically, copying the needs of your customer, maybe the company for whom you are developing your design, misunderstanding those with your design, your requirements for your system. And that's the role of systems engineers. And that's what we are going to be discussing about today. Same with architecture, the architecture of your system. That's something that system architects do. And now automotive companies are struggling to retain and to have that talent in-house. And it's important to have them in-house because you need to know the domain. They need to have experience in about car technology, basically, to understand how to design such a system. Same for underwater robots, flying robots. You need to understand the domain, but you also need to have this systems thinking, right? So this is a very pressing need in one industry, but hopefully a similar, well, that similar need is already happening in robotics. We are tired of seeing robots in videos doing amazing stuff, but we don't see that many products, that many robots around doing that stuff. And one key ingredient that is missing is systems engineering and systems architecting. So that's what we are going to be talking about today. So some months ago, I gave this set of talks a title, Model-Based Systems Engineering with the ISE and PPOA methodology, which is the methodology that Professor José Luis Hernandez and myself have been developing, especially himself. I'm just a collaborator, over the last 5 years or so, more intensively, or even more now. Well, the methodology is long. In robotics, it's the last 5 years or so. But this is a very complex title. So we will be touching those things, but the most important take of today for you is system thinking. That's what we are gonna be discussing today, how to think in systems terms and how to do practice of this. So today is about systems engineering, which is how we can deal with complex systems. And I have an example from the REMARO proposal here, the visualization of an underwater robots inspection system, ideally I have this thing here that I don't know how to take out. I don't know why I have this thing here. Never mind. So these kind of really complex systems that have, they require to integrate multiple disciplines. So we are talking robotics, but we are talking also fluid dynamics, electronics, software architecting, mechanics, and so the key element that distinguish traditional systems engineering from the one we are introducing here for you today, probably some of you already know about it, which is model-based systems engineering, is the move from a document-centric approach. So every engineering activity results in documents that other engineers take to continue the process. Now that's moving to a model, to data, which allows to automate part of the engineering process. But today we are going to be, there are a lot of tools for that, languages for that, we will discuss today. But today we wanted to have a more practical focus. So we are going to be focusing on the methodology. So the process of doing this model-based systems engineering, rather than the tools that you may change or evolve over time, we will be focusing on the process.